My name's Adrian McDonald. I'm a professor in the School of Physical and Chemical Sciences at Canterbury University. I'm also the director of Gateway Antarctica, which is Canterbury's Antarctic Research Centre. I'm an environmental physicist, so I deal with thinking about climate change and atmospheric science, understanding the nature using physical principles. Physics is broad-ranging, so it goes from looking at the very smallest things, so atoms, electrons, quarks, to stars and planets, and understanding how those things interact and understanding the laws of all of those things over a wide range. So physics represents science at multiple scales and very wide ranges, so from the very smallest things that we understand to the very largest things that we understand. There's a wide group of physicists at Canterbury, so we have people that are theoretical physicists and cosmologists. They think about things like dark matter, dark energy, and how the universe is evolving. We have researchers that are thinking about particle physics. We have researchers that are focused on developing new materials that can help to do things like develop the next generation of solar cells and solar panels. We also have medical physicists. We also have a number of environmental physicists. So there's multiple reasons to choose physics. So you might want an intellectual challenge. Physics is pretty tough for quite a few people, and you might want the challenge to be able to understand physics. There's lots of other reasons though. So for instance, there's really good transferable skills that are developed by learning about physics. The salaries are also pretty darn good as well. General interest as well, and learning for those transferable skills is, I guess, the most important things there. So physics obviously provides you an opportunity to learn about the theory and those laws that allow us to understand real-world problems. But that's only a small part of the skills development that happens in physics. So for instance, you do an awful lot of problem solving, so understanding how to work through real-world problems is really important and something that physics teaches really well. There's an opportunity to use quantitative skills and develop quantitative understanding and being able to apply that to problem solving, which is really important as well. There's also data skills. So more and more of modern physics is around using data and being able to program, being able to code, being able to use software, to be able to understand what the numbers mean coming out of laboratory measurements, out of just looking at data and being able to say, this is what this means, is a really useful skill. You also learn a significant amount of laboratory skills, so that can help to if you're interested in working in laboratory spaces, that's really useful as well. A first year physics year will be a mixture of physics courses, some mathematics courses, and also doing some computer programming courses, and then a range of electives to suit you. Those physics and mathematics courses allow you to develop a set of background foundations that allow you to understand later stuff. You will be doing laboratories, you'll be in lectures, you'll be doing tutorials and problem solving classes with your classmates. You would also probably be surprised, but there's quite a few opportunities to do field work. Some of the students that have done physics with me have gone on to visit Antarctica and help set up experiments in Antarctica. So there are a wide range of possibilities for physics students. Lots of laboratory skills, lots of interaction with experimental hardware, technology. University of Canterbury has a good record of our graduates going out to work in industry. So we have people that are working in the financial sector, in telecoms. We also have people working as meteorologists in the Met Service in New Zealand. We have people that are going to work as laboratory technicians and working in laboratories. To be able to start a first year in physics at Canterbury, you'll need NCA results in mathematics and physics. You'll also need to have done some calculus. Apart from that, we're just expecting good NCEA university entry requirements. So I guess there's a range of subjects that would combine well with physics. I personally think that environmental science is a great opportunity to connect between physics and environmental science, but I'm an environmental physicist. I think that there's good opportunities to think about connecting with chemistry and doing a joint physics and chemistry degree. I think that there's possibilities to work with the School of Earth and Environment around geography and geology and become a geophysicist, so understanding how the Earth system works. There's also good opportunities to interact with engineers. So the research that people do in physics overlaps very strongly with some disciplines in engineering, like electrical engineering and mechanical engineering. So that there's definitely opportunities to connect across physics to the engineering disciplines as well.